Ever since the iPhone 5S, Apple has claimed to have sapphire crystal as their iPhone camera lens. This includes the iPhone 6, the 6S, and even the iPhone SE. Sapphire crystal is a man-made material that is extremely hard and almost impossible to scratch with everyday objects, since it ranks about a 9 on Mohs scale of hardness, right next to diamonds. So it's a pretty big selling point when a company brags about using it. Tissot is another company that brags about sapphire crystal on their watches. It is even written right here on the back. So let's compare Tissot's sapphire hardness with Apple's sapphire hardness. These pics let me know where an object falls on Mohs scale of hardness. Glass, even tempered glass or Gorilla Glass, will always fall at a 5 or 6. Plastic will be a 2 or a 3, and sapphire will be an 8 or a 9. As you can see from my pics on this watch face, there is absolutely no mark until a Mohs 8 pic leaves the first visible groove. If you remember from my iPhone 7 durability test a few days ago, when I scratched the camera lens of the iPhone 7 with my pics, it left a visible mark at a Mohs 6, which led me to assume that the lens is just regular tempered glass, since it has the same hardness level. It was only after I made the durability video that I noticed Apple still bragging about the sapphire on their iPhone 7. So I figured it was time to test all of the sapphire iPhone lenses. Now, full disclosure, this hurts me, even more so than snapping a phone in half. I'm a camera guy, so deliberately scratching a camera lens, even for science, is extremely painful. I retested the iPhone 7 and got the same result. A 6, a 7, and an 8 pic all leave their mark, scratching much sooner than sapphire crystal should scratch. The sapphire lens on the iPhone SE also scratched with a 6 and 7. The iPhone 5S showed marks at a 6 and 7, and even the iPhone 6 scratched at a 6 and 7. So we can easily conclude that each of the iPhone sapphire lenses are much softer than the Tissot watch face. At this point, I thought the case was closed, and I got ready to post a video saying Apple just isn't using sapphire crystal. But I grabbed a diamond tester that I have laying around and tested the outer glass surface, and bewilderingly enough, it tested positive for sapphire, which is strange because as we've clearly seen, the hardness level does not match what sapphire should be. When I test the underside of the lens, the sapphire reading is much lower. Also interesting. I'll explain that in just a second. As you can see, when I test my Tissot watch face, it is off the charts in sapphire readings, but that is only because it is a larger surface area and easier for the machine to identify. Just for reference, this is a real sapphire. It's a pretty small stone, but still a level 9 on Mohs scale of hardness. This is just showing the mineral pics in action, as well as a control for the tester tool. So both companies claim to have sapphire, so why is there a difference in hardness? I looked at both my Tissot watch and iPhone camera lens under a microscope and found some interesting things. First of all, remember that this scratch on the watch happened at a level 8. We can see the damage pretty clearly under the microscope, the thin groove and the little chippings that permanently disfigure the crystal. But if we check the Sapphire iPhone 5S camera lens under the microscope, we can see something entirely different. Remember that this is the Mohs 6 line, this is the Mohs 7 line, and this crack here happened as I was lifting the lens out of the iPhone frame. The level 6 and 7 pics definitely did permanent damage, but under the microscope they look like small fractures instead of scratches. Still very permanent and still permanently disfiguring the lens, so it's pretty clear that we're working with two different qualities of crystal here. Now that we've seen this damage, let's figure out why Apple's lens starts to fracture at a Mohs 6, when it should be resilient to at least an 8 like on the Tissot watch, or a level 9 like we saw on the actual sapphire stone. So I checked Apple's patent for their sapphire information and found a few strange things. I will link this form down in the video description if you're interested in looking at it yourself. One of the very first things it says is that Apple's patent is related to thin sapphire laminates. Then down here it talks about laminating regular glass with a sapphire coating instead of having the whole thing be sapphire. Interestingly enough, because glass may provide cost savings over sapphire. It also specifically references camera lenses. So is that why the lens is fracturing? Maybe it's not solid sapphire. It could be just a thin laminate on top of regular glass because it would be more cost effective. I realized that in order to really analyze the lens before posting a video, I need some bigger toys. I headed over to a university where they have an XRF machine. X-ray fluorescence is a non-destructive analytical technique used to determine the composition of materials. Remember that this particular machine is only qualitative, not quantitative. So it won't tell us the percentage of each element, just if the element exists in the specimen. When I tested the outside of the lens, I get a huge reading of aluminum oxide, which means that the lens is most definitely sapphire on the exterior. When I test the inside of the lens, I get no reading for aluminum oxide, but I do get a reading for silicon, which is an ingredient of glass. This means that the underside of the lens is made of or coated with glass. But the XRF machine does not tell how thick each side is. So in order to find the thickness of each layer of the lens, I need an even bigger toy. Now this machine is an electron microscope costing close to $1 million. I wish I had one in my basement, but Santa keeps on ignoring my letters. Either way, in this test I have broken the actual iPhone 7 lens out of the phone. And here we are looking at the cross-section of the broken lens. This here is the total lens thickness, and this electron microscope is showing the actual elemental makeup of the lens. Thumbs up for science. The lens was cleaned before analyzing, and this is what we see during the scan. The different colors represent where the different elements are found in the lens. The carbon and silicon are not ingredients of Sapphire, only the aluminum oxide. So from this image we can pretty safely assume that the Sapphire we are looking at is not pure. There are a pretty hefty amount of contaminants, like the carbon and the silicon. Remember how my diamond detector tool had a lower reading on the inside of the lens? That's because there is a silicon layer that you can see here, but it is incredibly small in proportion to the rest of the lens, so it's pretty much a non-issue. I bet that the inner layer is more to minimize reflection or something minor, because structurally it doesn't seem like it would add any value. The vast portion of the lens is aluminum oxide. The graph here is quantitative, so it is giving us an accurate percentage of elements. Aluminum oxide, carbon, and silicon in this particular reading. Let's look at another segment. Remember that this side is the exterior, this side is the interior of the phone, and this is the profile of the crack. It has an incredibly thin coating of something on the inside of the lens, niobium and silicon. Niobium improves the refractive index of optical glass, allowing for thinner and lighter lenses, so it looks like that particular element is intentional. The majority of the lens body is the aluminum oxide, which is what we call sapphire, but we still have quite a bit of carbon, and that's the main impurity. Here is the quantitative graph again. The carbon is still a decent sized chunk. The niobium and silicon are just on that very tiny inner layer. Now let's take a look at the elemental analysis of the sapphire crystal on my Tissot watch. The only two elements found on the surface of the watch in the scan are aluminum and oxide, no carbon impurity. Also, the ratios of the Tissot Sapphire are very different than the Apple Sapphire. Apple only has a 2 or 3% difference between the aluminum and oxide, and Tissot has an almost 10% difference. Now, I am not a chemist, a geologist, or an engineer. I personally graduated in business. But these numbers sure are interesting between a lens that does fracture and a lens that doesn't. After filming and editing this video, I noticed one of MKBHD's most popular videos, which I will link in the video description. It is about the prototype Sapphire screen of the iPhone 6 that he posted a couple years ago. He came to the independent conclusion that it scratched at a 7 on Mohs scale, which, if that prototype was indeed a real piece of Apple Sapphire, it does match the same recipe that they are currently using for their camera lens. It makes me wonder if the Sapphire screen prototype and the current Sapphire camera lens both scratch early. Is the Sapphire Apple Watch made of the same weak recipe? And the bigger question, how impure can your Sapphire be and still call it Sapphire? In conclusion, just because my results show that the lens scratches earlier than Sapphire doesn't mean it's a bad lens. It is still scratch resistant, just like glass is, and the pictures are still great. It's just not as scratch resistant as we all thought it would be. If you like seeing technology reviewed from the inside, hit that subscribe button. My behind the scenes stuff can always be found on my Instagram and Twitter at ZachsJerryRig. Thanks a ton for watching. Hope to see you around.